Hello guys and welcome back to this amazing channel. This is Abhinav. So after a very long time we are back with our Codechef Starters 146 solutions. Yeah. So we'll discuss the top 6 problem, the first 6 problems from A to F of this particular contest, which is Starters 146. These are the problems you can see here, which is Olympics 2024, no winner, knockout tournament, permutation construction, bouncing ball and back front, right? So these are the problems that we will discuss. I will say this contest was later, so first 5 problems I will say were of very easy level. Well, they were not, I will say, very easy, but they were of a decent level. They were not very difficult, right? If you will see the summations of these first 5 problems, it is decent summations are there, like 29,000, then 19,000, 9,000, 7,000, 2,000. But the summations of the sixth problem is drastically decreased because that was a very difficult one, I will say, right? So we'll discuss till here, till this problem called back front, we will discuss, right? So let's start from first problem. So the first problem is Olympics 2024. What this problem says this, that Sefland has some G gold medals, S silver medal, and B bronze medal, and Sef will be happy if the team from the Selfland will win 5 medals of each type. So if there are less than 5 medals of each type, so that much number of additional medal they have to win to make the Sef happy. So they're asking how much is the total number of additional medal that teams need to win. So basically, we know that if the number of medals are less than 5, then whatever will be the difference will be the answer, and that will be stored in sum, right? So what I'm doing here is, I'm basically, if you will see here, I'm simply taking first 3 inputs A, B and C, then I'm taking a difference of both with 5. Okay, and if difference is greater than 0, then I'm adding into the answer. If 0 is greater, then it will be no difference, right? And that's it. Okay, so this is a very basic problem that we are having with a time complexity of order of 1 and a space complexity of order of 1, right? Amazing. Let's move forward. Next, we have this problem called no winner. In this problem, what they are saying is that basically there are, 3 person, Alice, Bob, and Cameron, and they have current their scores are A, B, and C. Now, what Seth plan? Seth plan to organize M more matches. So currently, Alice has a score A, Bob has a score B, and Cameron has a score C. But now Seth has actually planned to organize more M matches, M additional matches. Seth has planned to organize, right? And the thing is that if a match will happen, it will happen between 2 players, and one of them will win, obviously, right? दोनों में से कोई एक win होगा, and that person will get 1 point, right? So basically in these M matches, different person will get total M points, right? Now you have to find that whether it is possible to make the score of at least 2 players same. You have to make the at least 2 players score same, right? And for that we have M more matches, right? So what I'm doing here to solve this problem, it's again a very basic greedy problem, if you will see here. So what I'm doing here is that first of all, I'm simply saying ki what is the value of A, B, and C means the score of them, and M I have taken as D. Okay, now see. Up we will try for all. First, I will try that if A and B became same. First, we will try for A and B. So how we can make the score of A and B same? So first of all, I will find the difference between the score. So let's say the score of A is less, the score of B is greater, or whatever. If there's a difference between their score, so whatever is the difference, that much number of matches should be won by the person who has less score. But if we have that much number of additional matches, so if the value of D is more than the difference of A and B, then uh, A and B will have the same score, and this we will check for all the three tuples A, B, AC, and CB. So if any one of that, if the value of D is more than their difference, then the answer is yes. PY means print yes, I have the template, and else no, right? This is how we are solving this particular problem called no winner. It's again a very easy problem, right? Now moving to the problem number third, which is knockout tournaments. This particular problem is also, little on a good level. This problem says that there are some tournaments that has to be done between different players, and they are saying that there are 16 players only, right? And then you have to tell for each player how much maximum number of matches that particular player can win. कितने maximum match वो particular player जीत सकता है. That is what you have to answer, right? So for this also, if you will see, the solution is very basic. Okay, what we have done, it's a basic maths problem, but I will tell you how to do it. So basically guys, let me take the take the array. Okay, means the score of, or the, I think the skill, they are saying the skill of all the players, right? Up, see, you have to focus one thing here. The thing to notice here is that, just a minute. Okay, like this. Okay, now the thing to notice here is that we have this array. Okay, up, you have to find the maximum number of times, or the maximum number of matches that a person can win, right? That a person can win. And how the matches will be held? The matches will be held like this. Okay, I think we are not able to download this because it's a webp. So we can save this as why Codechef has webp images? It should be PNG, right? Let's convert webp to PNG. अरे भाई, URL दे सकता हूँ क्या? Unauthenticated. Okay, तो इसको पहले we have to download. Let's convert it to PNG. I hope that it is yeah, great. So we did a lot of thing to get it here. So this is how guys the match will actually happen. Let me zoom it little bit. Yeah. So this is how guys the match will actually happen, right? What is happening here is this is the whole array. Okay, this is the whole array. And they are saying that this is how the match will actually happen. Okay, a tournament. So basically, we have to find the maximum win by a player that can happen. कि भाई एक player कितने matches win कर सकता है? The maximum number of matches that can be win by each player, right? That is what we have to find. How we can do this, or how we can find this thing? Basically, see. So if we can know for every player how many players have less skill than them, so that player can win the matches than them, and we can arrange all those players in a ascending line, right? Let me give you example. For example, we pick for the player number 18. Okay, now let's find how many players are there whose skill is less than 18, because 18 can win from those players only. It cannot win from any other player, right? So if you will see, 16 is there, then 4 is there, then 2, then 7, then 9, then 15, then 5, then 10. So you can see these are some players which are having skill less than 18. I think so, right? If you will see, so 4 is there, 16 is there, 2 is there, 7 is there, 9 is there, 15 is there, 5 is there, 10 is there. All the values are greater than 18 if you will see, right? So means 18 can win the match from these players. So what I will do, I will arrange them like this. So first it will be like 15, 16, or in ascending order basically. So let's say it's 2, 4, okay. Then it will be 5, 7, 9, 10, 15, 16, and 18. Right. Maybe because after 18 a grader will come. So maybe replace this 16 with 18. So now from here 18 will win. From here 10 will win. From here 7. From here 4. From here 7 will win. From here 18. And then again 18. So basically you can see 18 has won the first match, the second match. Okay, this is not visible maybe. The first match, second match, and third match. So 3 matches, 18 has won. Why 3 matches, 10 has won? Because if you will see the number, or basically the players which are having less than 18, how many players are there, or how many basically these tuples are being formed. You can see there are 8 such players, and the value of log base 2 8 is 3. That is why the answer is 3. Because why log base 2? Because it's like a tree. Two players will win, two players will have a match, one will win, then they both will have a match, one will win. Okay, and the more the level of this tree, जितना इस tree का level जाएगा last तक, उतने ही number of matches it tail will play, right? So if you will see here, what I'm doing is that to first of all, how we can find कि how many numbers are less to a number, right? For that, what I'm doing, that I'm first of all, okay, here is the question. What I'm doing is that I'm first of all taking the input of all the numbers one by one, and I'm storing it in a vector of pair, because when we will sort them, we should know the index of every player which was initially, right? Now what I'm doing, for every player, after sorting, at whichever index that player is present, that means all the indexes before that are having a smaller player, and if we can get that number, we will simply find the log of that. So if a current player is at I, that means there are I plus 1 number which are less than equal to that number skill. So I'm just taking the value of log of 2I plus 1, right? This is what I'm taking, and as we will store the index in the second in the pair that I am accessing here, and for that particular index, for that particular player, I'm storing the answer, right? This is what we are having here. I hope that you have got the understanding of this particular video, of this particular problem. Okay, if you will see the time complexity, the previous one, here also time complexity was order of 1, space complexity was order of 1. Here if I will say the time complexity is n log n, because we are sorting the vector, right? So it will be n log n, not more than that, right? Amazing. Even I will not say n log n. Okay, wait. It will not be n log n, because the size of the vector is always same. So I will say here also time complexity is constant only, because we are always having 16 players, right? So here also time complexity is constant, what I will say, right? Now next is permutation construction. What is permutation construction? Here they are saying that you have basically have n numbers, okay, and you have to find a permutation such that the value of pi is greater than the value of pi plus 1 minus pi minus 1 chi square. Exactly. So basically they are saying that in a permutation, the value of a element should be greater than equal to the value of the square of the difference of their neighbor. Let me give you an example. If the permutation is like this, 218 216 if you will see here, they are saying that for every ith element, its value should be greater than equal to the difference, the square of the difference of their neighbor, means I minus 1 and I plus 1. For example, if you will see, if you will take this index, so if you will see, the value of this index is 6 and their neighbor is 1 and 3, so difference of neighbor is 2 and the square of the difference is 4. So this value is actually greater than equal to their neighbor difference square. It is fine. But if you will see this case, let's say this one. In this case, the answer is not true, because this one is not greater than the square of 6 minus 2. So you want that in every case, for every index of the permutation, your value of that index should be greater than the square of the difference of their neighbor. अब how you can do that? How you can fulfill that particular condition here? So see guys, for that what we will do, if you will see, this is completely observation based problem. Let's say if you are having two adjacent numbers, so what is the difference of those adjacent numbers? So difference of those adjacent numbers is always 1 and their square is also always 1. So if difference of two numbers is always 1 and their square is always 1, so means we can keep any number of the permutation in between them. Why? क्योंकि हमारे पास कितने numbers हैं? We have numbers from 1 to n. And if we know that two numbers have their difference 1, and difference 1 means difference square is also 1, that means any number can be kept in between ना, because कोई भी number सारे number 1 और 1 से बड़े हैं, right? So what we will do, we will always try that a particular number has their neighbor as adjacent numbers, so that if the neighbor adjacent number, so neighbor difference will always be 1 and their square will always be 1. For example, let's say my n is 9. So what I will do in this case, I will do 1 2 3 4 5. So up to n plus 1 by 2, I will have numbers, and the remaining numbers I will again have from the start in middle. So 6, 7, 8, 9. So you can see here now for every index, their neighbor are two adjacent number. For 6, 2 and 1 adjacent है, difference 1 है, square भी 1 है. Always condition true. For 2, 6, 7, 2, 3, 7, 8, 3, 4, 8, 9, 4, 5. So it was a completely observation based problem. So if I will say what you have to do, first of all, let's say if n is, let's say 8, then it will be 1, 2, 3, 4. As I said, up to n plus 1 by 2 you have to take, and then it will be 5, 6, 7, 8. That's it. So you have to print alternate numbers. So if you will see, first you will print, let's say if your n is 1, so first you will print 1, then your, and let's say, okay, let's say your n is 9. So what you are doing? So if your n is 9, so if you are saying here I is starting from 1, I will say, and there is a next number j is starting from actually n plus 3 by 2. This you can see, it's an observation based thing. So it will basically 6. Then I will be increased to 2, this will be increased to 7. I will be increased to 3, this will be increased to 8. I to 4, 8 to 9, and I to 5. And now finally all the numbers are there. So I will be printed up to less than n plus 3 by 2. And this j should start from n plus 3 by 2 and should go up to n. That is what should happen, and this is the observation that we have made. So if you will see how we have solved this problem. So how we have solved this problem is simple. I am first taking my I at 0, 1. So I is starting from 1. And I just said j is starting from n plus 2, n plus 3 by 2. Okay. And then every time if my I is less than n plus 3 by 2, because I should be from 1 till less than this. And j should start from here and should go up to less than equal to n. So while my I is less than this number and j is less than equal to n, I'm printing my I, and then I'm also increasing my I for the next iteration, and same for j. Okay, and then we are just printing, we are just changing the line. Okay, this is how, guys, we are solving this particular problem called permutation construction. Here I will say the time complexity is order of n only. Okay, because we are just printing the numbers right in a range, so it's just order of n time complexity, and there is no answer space complexity, right? Amazing. Now let's solve the next problem, which is bouncing bell. No, bouncing ball, sorry. अब देखो what this bouncing ball problem says. Bouncing ball problem says that you are having a like a number line thing where there are some value which are non-zero, there are some value which are zero. For example, let me show you a case. Let's say कुछ इस तरीके से दिया गया है. There are some walls present basically. There are some walls present. They are showing you, right? Okay. Like this, let's say. There are some walls present here. Okay. And now what they are saying is that in between there are some blank spaces also. Let's say I'm representing my red color as a blank. So first blank, second blank. So this is, let's say, zero height is there. Like this. Okay. Now what you will do, your ball will actually start from a particular point. Your ball will start from a particular point, and it should go in either of the position. Either, let's say, if I start my ball from here. Okay. So it will go here. Okay, I'm saying it will start from here. Okay, it will go here. So if I will give the heights also, just give me 1 minute. I will say this height is 1, this height is 2, this is 3, this is 4, this is 4, this is 3. Okay, now let's say I'm starting my ball from here. It will go to this position. It will make this height to 0. Now it will go to here. It will make this height to 3. It will go to here. It will make it to 3. Again go to here. Make it to 2. Make it to 2. Make it to 1. Make it to 1. Now it will make it 0. Finish कर देगा. It is 0. Now it will go here to here. Make it 1. Make it 2. Make it 0. Make it 1. Wait. ऐसा हो गया. Make it 2. make it 0, make it 1. अब यहाँ प्रॉब्लम क्या हुआ? The problem here is, अच्छा, by the way, this problem should not be there. Because okay, it is fine, it is fine. Yeah, अब you can see now here it's 1, and when it will come back, अब यहाँ पे कुछ नहीं निकल जाएगा. Thing is, you have to start such that कि सारे जो आपके पॉइंट्स है ना, सारे वॉल्स वो ब्रेक हो जाएं, और जो आपका बॉल है वो आउट ऑफ भी ना जाए. So basically your ball should also not go out of this range, and your all the walls should also be break. So you will only stop when your balls are break, when your also walls are break, right? अब see guys, one thing, what is happening? Your ball is starting from 1 point. Okay, अब it is hitting in alternative manner. First it is going left, right, left, right, left, right, left, right, left, right, and it can maybe start from a left and can end in a left. It can be start from a left and can end in a right. तो अब देखो, if you will see, if your ball will start from a particular point, जितनी बार वो लेफ्ट में जाएगा उतनी बार ही वो राइट में जाएगा. The number of times it will go to left, that same number of time it will go to right. और maybe एक कोई ज्यादा हो सकता है, means basically maybe it will go to left n plus 1 times, right n times, maybe right n plus 1 times, left n times, और maybe both same, या दोनों में सेम जाएगा. दो से अलग डिफरेंस नहीं आ सकता है कि यहाँ पे जाके फिर यहाँ जाओ और फिर दोबारा यहाँ चली जाए, नहीं हो सकता ऐसा, राइट? तो थिंग इज दैट if you are starting from a particular point, the sum of walls in the left and sum of walls in the right, their difference should not be more than 1. ठीक है, लेट मी गिव यू एग्जांपल. अगर हम इन सारी वॉल्स को, लेट्स से अगर हम यहाँ से स्टार्ट कर रहे हैं, हम इन सारी वॉल्स को एक मान लें. लेट्स से इट इज लाइक दिस. ओके, and I'm saying here there is a wall of 7 and there is a wall of 6. Okay, here there is a wall of 7 and 6. हमने मान लो इसका ऐड कर लिया, इसको ऐड कर लिया, इसको ऐड कर लिया, तो we got okay, I'm starting from here. Here there is a wall of 6, here is a wall of 7. Now it's better. So whichever side the wall is greater, let's say ये 4 है 3 है, for example, this is 4, this is 3. Better to understand. Okay, so how you will start? So whenever one wall is greater, one side wall length is greater, one side wall length is smaller, I'm taking all the sum walls, not a single one, but I'm taking all as a single wall, right? Whichever walls are there, don't care. मैंने सबको single मान लिया, right? तो whichever side, so first of all, the difference between the walls should be within 1. It should not exceed 1. I will give you the example. तो यार देखो, आपके wall दोनों जो है, first case क्या है कि the left wall is greater than right wall, सिर्फ एक से. तो what is happening? You will start from the right, left, you will make it like it is 2, it is 2, it is 1, it is 1, it is 0, it is 0. Now you can see that both the walls have become 0. कोई दिक्कत नहीं है. कितने हुए? And you can see in this problem you have to tell the number of ways, right? So you can see one number of ways there. When there is one number of ways, when left is one more than right. Similarly, if right is one more than left, let's say right आपका हो जाए कुछ इस तरीके से 5, then start from right. So here 4, here 3, here 3, here 2, 2, 1, 1, 0, 0, then also it's fine. So when the difference between the left and right ball is 1, when difference between left and right ball is 1, that means we can either go for whichever is the greater. So if left is greater than right, you will start from the left. If right is greater, you will start from the right, and you will have one number of way such that all the walls are destroyed. And if they are equal, अगर दोनों equal है मान लो, if they are equal, ये भी 4 ये भी 4 है, then you can start from any of the side. You can start from left also and you can start from right also. इस केस में क्या होगा? Two different ways are possible, either left, either right. But the thing is, when the difference is more than 1, let's say the difference is 2. Now if the difference is 2, that means you cannot start from any of that, because if you will start from here, okay, so it will become 3, 1, 2, 0, 1, and it will go out of the range. It will never come back to that 1, and that will be still 1, right? So first of all, difference should be within 1. So now if you will see here how I'm solving this problem. So I think I made it a little complex. Let me make it. And obviously, this should only be done when current is a zero height, because ball should be there when there's zero height. So if we can know that a current index where we are, so what's the sum of the walls before it and what's the sum of the walls after it? If we know that, then we can compare them, right? So what I'm doing here is that I'm first of all taking the input, that in this sum I'm storing the sum of all the walls, जितनी भी walls है मेरे पास उन सबका sum आ गया, right? The sum of all the walls, sum of all the walls, right? Now what is happening, this current sum will store sum of all the left walls. Let's name it as left sum, right? Up, and initially left sum is 0, because initially we're starting from index number 0. So for index number 0 there is no left wall, so initially left sum is 0, right? What I'm doing is that if your current vi is 0, obviously, because you have to place your ball whenever the value of vi is 0, then only you can place your ball there. And now you will see that whether there is any possible way to destroy all the walls, how you will find. So you know the left sum, and guys, if you will subtract the total sum from this left sum, then what you will get? You will get the right sum. तो आपका, you know कि total how many walls are there. You know total what's the height of the wall, and if you, from the total height of the wall, if you will subtract the left height, then the right height you will have. And if the absolute difference of right sum and left sum is 0, that means how many possible ways are there? So if absolute difference is 0, that means you can either go to left or either go to right. Both are fine. So answer will be added by 2. But else if this absolute difference is 1, that means it will be 1 only. And if absolute difference is more than 1, that means we cannot. And for the next iteration in my left sum, I will add my vi. That's it. This is how we are actually solving this particular problem. I made this code little more easy, right? Exactly. You can see, and let's submit it also, right? So guys, this is how we are solving this particular problem called bouncing ball, and you can see it should be submitted successfully. Oh, wait. क्या हो गया? It failed. Why? Uh, okay. Previous case was working fine. Why this one failed? Let me check. Have they added some extra test cases? I didn't did much change, I think. I didn't did much change. Basic change only I did. Right sum is sum minus left sum. We can start our for from I up to n minus 1, because you just check for the middle one, and then initially you can have your I as the vi. This can be one of the approach. This is always not required, by the way. So absolute difference of right sum minus. So what I was doing previously, how it got. Okay, do they provide video links also? Acha, okay. If you have the premium. So this was my solution earlier. How this was working and this is not working. I did the same here also, right? This was actually a little more complex. So I thought to have a better solution. But why it is not working? Let me see if this is working. Or if this is also not working, that means they must have added some extra test cases that we will figure out. But if this is working, that is not working, then it's a problem, because the logic is same. Oh, this is working. That means we made some confusion here. We made some problem. So the absolute difference, if it is 0, that means answer will be added by 2 because we have both the possible ways, right? This side and this side. If it is 1, that means if absolute difference is 0, that means they are equal, means you can go on both the side. If absolute difference is 1, that means you should go on a side which is having higher, and this will be increased. If absolute difference is more than that, means nothing will be added, answer will be as it is. So what is the problem here, bro? Let me submit it again. What is this, bro? What is this? Okay, so it is failing for this. Your output this, and my output is this. Okay, okay, okay. So I think this code does not have any zeros. Ah, this is the input file. Yeah, this does not have any zeros. And the case, okay, it has a zeros in the middle. Bro, I think I got it. Bro, I think I got it. I think I got it. It should be long, long. Set. It should be long, long. That is what we were missing. Actually, integer will not be taken. It's a very huge case. And that is what I thought. Ki we are doing everything right. Why it's not working? Yeah, so it should be long, long. Actually, guys, this right sum we have taken as integer, right? It was going out of bound. Otherwise, everything is right. So I hope that you have got the understanding of this particular problem. The time complex is order of n, and there's no actually space complexity, right? Which is bouncing ball. Okay. Cool then. Now let's finally discuss the last problem, which is back front. This was a very interesting problem, I will say, and I'm not sure how others have solved this problem, but I have solved it in a very, very, very basic ad hoc manner, a very brute force way, if you will say. वही मैंने किया है. I will also explain you that how we have solved it, right? So, okay, let's discuss this problem. So finally, in this particular problem, they are saying that there's the back front, right? So we are having a string, okay, where they are saying that we have to choose a substring of the string that equals back. So in that whole string, you have to pick a substring back, okay, not a substring, sorry, subsequence back, and then you will delete that subsequence from S. Then what you can do, you can actually choose any character whose ORD is having at most two divisor. And if you know, guys, uh, a number which has at most two divisor is a prime number. So basically, you have to pick a character whose index or whose ORD, ordering in alphabet is a prime number. You can choose that number, and then you can insert it in the S at the start. And then second operation that you can do is that you can actually choose, you can take a subsequence front, and then you can delete that front, and then a number which is not prime, a character whose ORD is not prime, means who has more than two divisors, that you have to append at the end of the S. So first of all, let's see which are those character which has at most two divisors. See, it's at most two. So even if less than two divisors are there, for example, for one, that will also be considered here only, right? So if you will see the characters having their ORD with at most two divisors or less than two divisors, which are those characters? So I have actually written it previously. So those characters are A, B, C, E, G, K, M, Q, S, W. Right? These are those characters whose ORD is odd. And the remaining characters have the ORD not odd, have more than two divisors, right? So basically, these are some characters which can be replaced by back. So if there is any back we will find in a string, we will remove that back, and any of these characters can be added at the start of the string. And if there is a front there, so whenever you get a front, you'll remove that front substring and any character apart from this will be added at the back. Up see guys, we don't need any other characters from B, A, C, K and F, O, R, N, T. We don't care because they are saying that we need to perform these operations so that finally we have minimum possible string of our answer, right? So see guys, how we can do it. We will try to get more number of subsequences of this back and front so that we can just remove it from the string and we have less number of final answer, right? So what I will do is, for example, back mila, so whenever I will get a back string I will remove it, and now any of these characters I can add at the front. So if I can add at the front, that means I can either choose BACK or FRONT. We will see any character from FRONT is not present here. Means when you will remove a back, you will have to either insert a B, A, C or K so that maybe after inserting it, a different back is being formed. तो यहाँ पे आपको B, A, C, K मिल रहा होगा, ठीक है? And when you will remove front, then definitely at the last you will add something of FRONT only because that will be needed. Now let me give you an example with some test cases. For example, this is the thing. Okay. So how you will solve the problem here? It is a pure observation based thing what I have solved. Maybe people have solved in a better way, and maybe my solution is very complex, but that is how I have solved in the contest, so I can explain that only. Right. So what we have done here is that we will first of all have the indexing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, 13 and 14. I think it's of okay, exactly. Okay. Up see guys. Obviously, what we can do first, let's check for back. पहले चेक करते हैं हम लोग बैक के लिए, ठीक है? अब see guys, we know that कि whenever we have a back substring present in this particular string, we will remove it. After removing it, we can add either of the B, A, C, K in the start. And which you will add? So for example, अगर already in the substring A, C, K is present, if we know that there is already a C, K is present, then you will definitely add a B and it will become a B, A, C, K. If you add a B at the start, A, C, K is already present, it will become B, A, C, K. Means one more substring you will get. How to get that? So first of all, you will see, first of all, you will find ki how many substrings are present here, how many back are present, then how many ACKs are present, how many CK are present, or how many K are present. All of these four things we will find in this particular string. How we can find? See, what I will do, initially I will start from the back. So I will do one thing. Let's take a better example from this. Let me take one example. So let's say the example is like this. So here I will take this. Yeah. So for example, the example is like this. So I'm first of all, see, here I'm not talking about front. Abhi front ko bhul jao. Forget about the second operation. Let's first see how we can optimize our back. Okay, forget about the second operation. पहले लोग back के लिए कैसे करेंगे? तो how we will do for back? For example, हमारे string कुछ ऐसे है. ठीक, अब देखिए आप, हमें क्या करना है? What I will do, if you will see my code, I will also explain my code side by side because otherwise it will be very hectic. It's a very long code if you will see. So I will explain my code side by side. Okay, what I have done. So first of all, I am doing, if you get a character K, I will increase the map value of K. When I will get a C and K is already present and I'm going from the back, right? हम यहाँ पीछे से iterate कर रहे हैं. So what I will do, whenever I will get a K, that means I got a K, I will increase the frequency of K. When I got a C, that means this C can be mapped with the previous K that we have got. So if the current character is C and previously we have already got a K, that means reduce that K is gone and now CK is there because ये C उस K से attach हो जाएगा. Now when you got a and already a CK is present, so remove that CK and add ACK. Now if a ACK is present and a B came, so decrease that ACK and now back will be increased, right? Why we are calculating this ACK, CK and K, that we will discuss later. For example, in this case, if you will see, in this case, I will go from the back. Okay. First you can see I got a k. Okay, so I will increase k. So now the frequency of k is 1. Now I will get a c. I got a c. When I got a c, k was already present. Okay, when I got a c, k was already present. So I will reduce this k by 1, and now this whole ck will be considered as 1. Now one more k I got, so okay, increase it. Now I got a A. When I got a A, I will search for CK because A should be added before CK, and CK is also present. So I will decrease this CK, and now ACK is present. And these all are substrings that subsequences that I'm talking about, right? These subsequences are present. So now we know that there is one subsequence of ACK and one separate K is present, right? You can see ACK and one separate K, right? Amazing. Now we got one more K. Okay, increase it. Now we got a C. When we got a C, that means I will reduce 1k and 1 ck will be increased. Amazing. Now we get a R. R we don't require. If it's R, ignore it. Again we get a C. Is there a K? Yes. So K will be reduced and ck will be increased. Amazing. Again we get a K. Increase it. C. Okay. K will be reduced and ck will be increased to 3. Now we have 3 ck. Now we get a F. Ignore it. Now we get a A. When we got a A, so one ck will be reduced and ACK will be increased. When we got a B, that means ACK will be reduced. एक ACK को हटा दो, and instead of ACK get a BACK. क्या हमें अब पूरा एक BACK मिल गया, right? Now again A means reduce CK and increase ACK. Again A, reduce one more ck and increase one more. Okay, let's do one thing. Let's not decrease this. I have turned all the cases. Let's see this A is not there, right? Amazing. Now we get a O. O is not required. Okay. Then we get a B. B we got. So when we got a B, this ACK will be reduced and back will be increased. And then we get a Z. Z is not required, right? So if you will see final, you can see that. And let's add one more K here so that I can have this K as 1. So finally you can see that, or let's say एक CK और यहाँ add कर दो, हाँ एक CK और यहाँ add कर दो. I want one more CK. So finally we can see in this string we have one subsequence, a single K, two subsequences of CK, one whole subsequence of ACK, and two subsequences of BACK. ठीक है, अब देखो, अब अंडरस्टैंड वेरी केयरफुल. आई विल रेज दिस ऑन. ठीक है, अब हम क्या करेंगे? सबसे पहले वी नो दैट कि दिस इज द होल एरे. तो इन माय आंसर फर्स्ट ऑफ ऑल आई विल टेक द लेंथ ऑफ दिस होल स्ट्रिंग. क्या लेंथ है? सो 3 6 9 12 15 18 20. सो इसकी लेंथ 20 है. तो इनिशियली आई विल से कि माय आंसर इज 20. आई हैव नॉट रिड्यूस एनीथिंग, राइट? अब सी, whenever you will reduce something, what you will reduce? So you will see that 2 back will be reduced because back you can directly remove. But see, when you will remove a back, that means you have to also add something in the start, and it will be obviously either B, A, C or K. So अब क्या करोगे? If there are 2 backs present, remove it, make it 0. And when these 2 backs will come, each back contains 4 characters. So basically 8 characters are subtracted from the answer. So if you will see what I am doing, after calculating this, if I have some back, if my number of backs are greater than 0, so what I am doing, I am first of all taking how many backs are being removed, because the number of backs will be removed, that much number of operations we have to do. मतलब उतने हमें characters add भी करने होंगे. That much number of characters we have to add also, right? So here in something called operations, I will make it at 2, and this I will reduce. So you can see from my answer, I subtracted 4 into number of backs. So here back was 2, so I've subtracted 8, right? अब देखो guys, अब we know that कि this back is gone. So let's say this B A C K is gone, then this B A C K is gone. So 2 backs are gone. They are done. अब we know that कि there is one ACK present. We know there is one ACK present, and in this one ACK, if we can just add one B, तो हमारे पास 2 ऑपरेशन है. अगर इस 2 ऑपरेशन से हम लोग एक B यहाँ पे ऐड कर देते हैं, अगर हम एक B यहाँ पे ऐड कर देते हैं, let's say I add one B through these 2 operations. Now अब only one operation is left. Now because of this B, ये जो एक सी ए सी के था ना वो भी हट जाएगा, दैट विल आल्सो बी रिमूव. सो बी ए सी के, दिस इज आल्सो गॉन, एंड बिकॉज ऑफ दिस विच इज रिमूव्ड एक और यहां पे ऐड हो जाएगा. तो अल्टीमेटली आप देखो क्या हुआ कि ऑपरेशंस वही रहे, ऑपरेशंस टू ही रहे, आपको जो ए सी के था ना वो भी हट गया. Operations remain same and your ACK is also removed, because whenever you will do one operation to add a B, that ACK will become BACK, it will be removed, and then one more operation you will have because that BACK is removed and it will give you one more operation to do, right? तो आप देखो कि जो ACK हैं, that ACK are being removed without any extra operations, you can see here. So what I'm doing, I will simply remove all the ACKs, and if a ACK will be removed, each ACK contains 3 characters, so 3 into number of ACK. So you can see here there were 1 ACK only, so minus 3 will happen. Now you can see remaining are the 9 characters which are remaining. You can see. Now when ACK are done, now I will take for CK. अब देखो CK में प्रॉब्लम क्या है? In CK we have some CK, we have to add 2 things, a B and a A. Means we need 2 operations for this CK. Means I have to take 2 operations, I have to give 2 operations, and at the back I will get only 1 operation. मतलब मान लो अगर हम ये 2 ऑपरेशन यूज करके I will add here a BA, so this BACK will be gone and I will get 1 operation back. So basically here number of operations is reduced by 1. So every CK is taking 1 number of operation, and also we can only perform this CK operation when we have at least 2 operations remaining, because this CK needs to add BA और फिर एक ऑपरेशन वापस आ जाएगा. So it will eventually take only 1 operation, but we should at least have 2 operations. 2 will go, 1 will come back, right? So if you will see, if my total number of operations minus 1 is greater than the MP of CK, that means that we can also perform operation with CK. So what I will do, I will subtract that much number of operation, because if there are 5 CKs present, that means it needs 5 operation to get removed. That will be removed, and in my answer also 2 into CK, because CK substrings are gone, CK subsequences are gone, each CK is of size 2, just like we did here also. And now finally, and अगर देखो अगर ये ज्यादा नहीं है, then whatever total operations are there, उतने आप CK remove कर दो, that much number of answer will be reduced, and finally at the last 1 operation will be left. For example, here we are having 2 operations, we add a BC, तो BC with CK, BA with CK, removed it, but again 1 ऑपरेशन लास्ट में एक आएगा, लास्ट में एक ऑपरेशन पक्का बचेगा, बिकॉज जो लास्ट में BA CK जाएगा ना, तो लास्ट BA CK which will go, 1 will be remaining, right? That I am increasing here answer. Try to understand, okay? Now finally came for K. और जो फाइनल केस है K, वो जो कैसे हो रहा है, अंडरस्टैंड वेरी केयरफुली. अब लेट्स से फाइनली वी हैव ओनली 1 ऑपरेशन रिमेनिंग. By the way, for K we need at least 3 operations, because if there is a K and we need to add BAC, so at least 3 operation remaining है. That is why you can see what I'm doing is I'm saying total operation minus 1 divide by 2 should be more than K. Why? क्योंकि देखो हमें एक ऑपरेशन तो चाहिए यहाँ पे मान लो C ऐड करने के लिए, और हमें 2 एक्स्ट्रा ऑपरेशन चाहिए, क्योंकि जब BAC के डालेंगे ना तो ये चला जाएगा, we will get 1 operation back. So eventually what we will do, we are giving 3 operations and we are getting only 1 operation. हम 3 operations दे रहे हैं बट हमें एक ही ऑपरेशन मिल रहा है वापस, राइट? आर यू अंडरस्टैंडिंग? एक ऑपरेशन मतलब ability to add one more character, right? तो eventually in every step we are losing 2 operation. तो अगर हम सारे ऑपरेशन 2 का डिवाइड कर लें तो operations by 2 is the number of times we can reduce this K. So if this operations by 2 is greater than K, the same thing which they did here, subtract from answer, subtract from total operation. तो total operation क्या है? एक K के लिए 2 ऑपरेशन लग रहे हैं, तो subtract that, and every K contains only 1 character, so that will be reduced from the length, and then finally, and अगर नहीं हो पाता है, so this case will be used here, and finally whatever is the remaining number of, for example सब होने के बाद भी 10 ऑपरेशन बच गए, 10 ऑपरेशन आर रिमेनिंग, तुम 10 ऑपरेशन में क्या करोगे? आप पहले एक BAC के डालोगे उस 10 के लिए, 4 का यूज किया, 4 का यूज किया, एक BAC के डाला, उससे एक वापस आ गया, फिर 4 डाला, एक वापस आ गया, because for every BAC 1 will come back, right? So eventually what you will have is total number of operations mod 3, because 4 are going, 1 is coming, so every time 3 are being loose, तो कितने 3 का पेयर बनाओगे, एंड फाइनली आपका एक तो बचेगा ही बचेगा लास्ट में, At least one, right? This is how we are solving this particular problem. Actually, I understand it is really complex. Maybe I have also done a very fast way of explain, because see, it's a pure observation based thing. If you get the observation what I'm trying to do, implementation is something that you have to do. Don't go with my implementation. Don't go with my implementation, because that is what I thought of. Just understand the logic that I'm going to tell. If you understand the logic, you can implement it by your own. And see, guys, the same thing I'm doing for the front also. The only difference is from front, because we have to add characters from the back. I'm not checking for K, C, K, O, C, K, A, C, K or B, A, C, K. I'm checking for F, F, R, F, O, R, and so on. Let me give you a very basic example of that also. Let's say it's like this. Okay. So what I will do, now here I will start from the front. So I will see, okay, first F is present, cool. F is 1. Now R is there. If R is there, there should be a F before. F is also before. Okay, so F will become 0 and FR will become 1 because we got a FR. Right. The same logic, just for back, here we are going from front. And the only difference is here we are going from the front. Okay. Now it's a T. Up before tree, O should be there और फ्रो शुड बी देयर FRO. अगर करंट T है तो उसके पहले कुछ FORAON होना चाहिए ना फ्रंट बनाने के लिए. देयर इज नो मूव फॉरवर्ड. N is there. O is there. Okay, if there's a O, make FR 0, FRO 1. Is a N, make FRO 0 and FORN 1. Right, and so on. There's a B, ignore it. C, ignore. R, okay. If there's a R, is there is a F before? No, skip it. T, skip it because there is no FO. Okay, T you got now. FORN will become 0 and then FORNT will become 1. Again a F, okay, F will become 1. O, there is no FR. N, there is no FRO. R, yes, there is a F. So remove it, add it. O, again, 0 it, add it. N, amazing, remove it, add it. T, remove it, add it. O, no, and no. So basically यहाँ पे आपको finally सिर्फ दो FORNT मिल रहे हैं and nothing else. No other subsequence is being formed. So basically just to give the logic ऐसे किया है, and then again you can say this logic is also exactly same, and remaining logic is also guys exactly same in FORNT. The only thing is because FRONT front contains 5 characters, back was containing 4 characters. बैक में हमने सिर्फ बी के लिए चेक किया, लाइक बैक के लिए, देन ए सी के एंड के. यहाँ पर एक आइटरेशन बढ़ जाएगा विच इज फॉर फ्रंट. then front is taken initially, then total number of operations front I have taken. Then we know that कि FRON will also be done as it is. कोई extra operation लेंगे, एक गया एक आया, one operation will go, one operation come. Just like here it was ACK, here it is FRON. Now just like here we are checking for CK, because in CK we need 2 will go, 1 will come. So same here it is for FRO, 2 will go, 1 will come. Same logic. Now there it was K, here it is FR. Up here it is after FR, one more thing is for single F, and the same logic I have applied here, what I have done here. So it's just guys, if you have got the understanding of the logic of the observation which I made, then you will eventually understand the problem also, right? That how I have solved it. So I know that it is a little complex thing that we have done, but yeah, try to understand logic. Don't try to understand my solution, it is very complex. Just try to understand the logic, the observation I made, and then try to implement by your own, and maybe other people have solved it in a better way. So guys, I hope that you have got the understanding of this particular problem and the whole 6 problems of this particular content that we discussed. Still, if you have any doubt, do let me know in the Telegram channel, or you can ask that to me in the comment section also. Thank you. Take care. Bye.